Hello everyone, this is Abhay Sharma for thinkingpenguin.com and welcome to another tutorial. Today we are going to take a look at BVH-TREE in animation nodes. It is sort of like KD tree but it works with geometries. So BVH-TREE or bounding volume hierarchy tree is also a search algorithm which is being used in many ray tracing render engines or physics engine etc. Let me create all the BVH nodes first and then we will talk about them one by one. Okay, to use a BVH tree, we have to construct them first. Let's grab the construct node. There are two modes. By default, it is set to mesh. Connect the vector list and polygon indices to BVH node to construct a BVH tree. Select your geometry. Let's change this to BMesh. So now we need a BMesh. Performance wise, I think BMesh is more efficient. If you delete this cube and create something which has more vertices like Suzanne, although Suzanne is low poly head, but this will do the job. Change the BVH mode to mesh. Select Suzanne in our object mesh data and connect it. If you look at the performance counter, you can see it is between 1.0 to 1.4 milliseconds. Let's grab one of the BVH node, find nearest surface point. Create a sphere, scale it down, move it. I'm going to give it a red color. Let's import the transform information in animation nodes. Select the sphere and connect it to the find nearest surface point node. Now I'm going to duplicate the sphere and also duplicate the material. Scale it down, create a transform output. Select the yellow sphere and connect the location data to BVH nodes vector. Now if I move the cube, the yellow sphere follows it on the surface of the BVH geometry. Looks like a projection to me. BVH tree finds the nearest surface point relative to sphere's location. Look at the performance counter, it is around 0.9 to 1.0 or something. Let's change the mode to BMesh. Now we need a BMesh from object node. Select our Suzanne and connect it. Now the performance counter is around 0.6 to 1.0, definitely less than the previous mode. It will become more apparent if you use a more heavy geometry. Okay, so there are few interesting outputs you get from nearest surface point. Most of them are straightforward. This hit output is interesting. It says if the object is in a specific distance, which you can change it from here. So if I change this to 1, it becomes false. The values are grid units. Okay, the nearest surface point node only considers the object location. So if I rotate the red sphere, it does not have any effect. Let's delete this node and grab the other one, raycast BVH tree. This node will consider location and rotation. Let's connect the location to ray start, and if you see the output of hit, it says false because right now the ray direction is facing in the wrong direction. If I go to the wireframe mode, you can see the yellow sphere is in the center, basically unaffected. Let's connect the red sphere's rotation to ray direction. Let's switch the direction to Y and it starts working. Now if I move or rotate the red sphere, it affects the yellow sphere. Well, this is a very crude example. Let me show you a cool example from Jack's Luke. He created a render engine with raycast BVH and with the help of other nodes. Go to the Jack's Luke YouTube channel and find this video, Timeline Renderer Animation Nodes Fun Project. If you are really interested in BVH, you should definitely check this out. It's insane. Alright, let's move on to the next one. Is inside volume. Let's delete unnecessary stuffs. Is inside volume is really interesting node. It will give you a boolean output if a specific vector is inside its volume or not. I'm going to create a particle system, then I'm going to make some quick changes. Let's connect the BVH tree to is inside volume node and delete this mesh data node. Let's create a cube, make it big. So all the particles are going through this cube. Let's change the cube display settings to wire. And also I'm going to make this unrenderable. So let's change the render engine first, then turn off all the attributes in cycle settings. Let's rename this cube to container or whatever you want. Select the container as our B mesh. Now we will check if a certain particle is inside the volume of the container mesh. So let's import the particle system, then filter it out based on the particle state. Create a particle info node to access single particle properties like location, rotation, velocity, etc. So connect the location to inside volume node, and if I see the output it says false because right now the first particle of particle system is outside the container's mesh volume. If I go to the first frame, it says true, which is strange because right now particle is not born yet. But let's move the playhead. Our particle will born and move through the container mesh volume. The moment it enters into the container mesh volume, boolean value changes to true. When it moves out, it changes back to false. That's the basic functionality of is inside volume node. It gives you a boolean value, and based on that you can activate whatever action you want. In my previous tutorial, AN groups, I have used BVH-TREE to trigger animation if a specific object is visible inside the camera view. And I got a comment from Adriano about how to change a particle object from cube to sphere halfway through its lifetime, or if it is at a specific distance from the emitter. Well, this can be easily achieved with BVH inside node. Second comment I got from Michael Larsen, who wanted to know if it is possible to change particles color if it is inside or outside a volume object. Yes, it is possible, and I'll show you how you can do this in this tutorial. First, I will show you how you can change the particles object from a cube to sphere, then how to change the particles color if it is inside the container's mesh volume. Let's get started. For instancing particles, I'm going to use animation nodes. Delete particle info and get list element node, then create a particle list info node. Now we're gonna loop through particles location list. So create a object list iterator, create a cube object, then an instancer. Then you already know what I'm going to do because you have seen me doing this a million of times in this tutorial series. Now I'm going to turn off these relationship lines from viewport. Select the instancer node, go to the panel settings, and under advanced settings hide relationship lines. Okay, so everything is working as expected. Let's create a sphere object and move it here. Now we will change each cube inside this container into spheres. First we need to build a BVH tree, which we have already built it, so I'm going to move them inside my loop. Create a new object parameter and select our container mesh. Let's convert this into B mesh. And we have got a BVH tree. Now based on this BVH volume output, I'm going to change cubes into spheres. We need a switch node and a copy data node. Okay, if the condition is true, it's going to pass that specific cube object. Then connect the output to copy object data node. It seems like we should connect it to the from input, but we have to connect it to the to input. Why? Copy data object exchanges the DNA of the object. It sort of works like a virus. It infects the cube and make it a sphere. So select the sphere as our from object and cube as to object. And you can see that whatever cubes are inside volume object became spheres. But it does not changes back to cube when it leaves the volume object. Well, depending on the result you are expecting, it may be fine or may not be fine. So if you want to make those spheres back to cube, we have to force it. Duplicate the switch node. This time connect the object which is spheres now to if false input. Duplicate the copy object data node. Select the cube as from object and spheres as to object, and it's done. If I move the container or volume object, it affects particles in real time. Let's move on to the next example, changing particles color if it is inside or outside the volume object. I'm going to delete all the unnecessary nodes and objects. This time let's use the standard way of particle instancing. Let's increase the size of the particles a little bit. Changing the color of the particle node through animation node is kind of tricky because we do not have enough options available. Let's give the particles a material. Now we can choose that material in Cycle's material output slot. Choose diffuse BSDF and then we can control the color. If we change the color, it will affect all the objects, not the selected one. We cannot use Cycle's material output inside a loop to instance it. So what choice do we have? Let's switch the mode to material and I'm going to change the shader to emission to make it simpler. Let's turn on the viewport render preview. Okay, it's not applied to the particles. Let's select the sphere object and change its material to particles. There are few nodes we can use to control the material on per particle basis. There is attributes, but I have no idea how to use it. Then we have object info and particle info node. I'm going to use particle info. It would be awesome if animation nodes and Cycle's material editor has a connection. Perhaps we could add a custom attribute to particle info, but right now I have no idea how to do that. So what I'm going to do is I'm going to control one of the properties of particles listed here and use it to change the particle's color. I'm going to use the size attribute. So basically I will affect the particle size from animation nodes and then change the color based on the particle size in material editor. Let's switch back to animation nodes. To set the size of particles, I'm going to use a single line script. So right now I am looping through particle location, but what we need now is to loop through particles list so that we can get access to individual particle properties. Okay, add a particle list as an iterator. We do not need the vector list iterator, so just delete that because particle info node will give us location as well. Create a particle info node. Now connect the location to isInside node vector output. Create the script node. Add a particle input, a boolean input. Let's rename it just to refrain it from conflicting with reserved keywords. Create the script file. Change one of the viewport to text editor. Select the script file. Create the invoke node. A float to control the size. Okay, now we write the script. If the boolean is true, then change the size of particle. It's displaying an error message. None type. Object has no attribute size. Well, we need to feed the particle into invoke subprogram. Just connect the particle input from loop. Alright, now we can control the size of individual particles based on the boolean output. Let's connect the isInside output boolean value to activate. And now it will only affect the particles that are inside the volume object. Let's change the color in materials editor. Turn on viewport render preview. Create a color ramp node. Connect the size to factor and output color to shaders color. Adjust the sliders, and there you go. I'm gonna make this particle a little smaller. When we are using the viewport render preview, animation node does not update, so make sure to refresh it. Alright, that's it. As far as the basics of animation nodes is concerned, from the perspective of visual scripting, I think I'm done. If you have any suggestion, please give your valuable feedbacks in the comments. Alright guys, I hope you liked this tutorial. If you liked it, then please subscribe, give it a thumbs up, share or comment. Thank you so much for watching, and I'll see you in the next tutorial.